Bring us to fallacy number 6. The administrator will know what to do. Now, in a small network, a relatively small system where you have the person that built the system is the person that is still running the system. So often you'll have this in the types of environments that you were describing before in the MOD, where somebody built something and they've been babysitting it, in essence, ever since. They know everything there is to know about all the configuration, the databases, the environment variables. They know the code inside and out. This is the one case where the administrator truly knows everything that there is to know about the system until the agile truck factor gets involved. I never really liked the agile truck factor. I prefer the why couldn't they get promoted, move to another company? They don't have to get run over by a truck for us to lose that godlike administrator capability. Thing is that once they move on, for whatever reason, their replacement won't know what to do. So we need to start from the assumption that the people who are administering and monitoring our systems don't really know everything that there is to know about them. Now, coming back to the developer side of things, because most of us are on the developer side of the equation, thing is we don't often know everything there is to know about the system. Let me ask you this. Who knows what every bit of configuration in their system does? Okay, got one hand going up. 2 out of 34. All right. How many of you think you know what all of the configuration does? The problem with configuration is it starts very innocuously. It's the, well, we need connection strings and we need all sorts of physical things. And then along the way, two developers are having a conversation of, should we make it do X or Y? And then they kind of go back and forth, and nobody's really able to convince the other one. The answer is make it configurable, right? Then we can decide effectively not to decide right now when the system goes live. We can flip a switch and make it go this way or that way. And the more configuration options that we create, the less likely that anybody's going to know what a given set of specific knobs and dials is going to end up doing. And that results in sort of this voodoo type of experience of, well, it worked yesterday. It doesn't work today, and we're kind of doing a diff, and all the config looks the same. Did you look at the database? That's part of the problem with configuration, is that half of it ends up in a database somewhere, right? And then another half is in environment variables or config files or various other types of locations. And it's really hard to understand what exactly a given change is going to do. So this relates to the whole multiple administrators. The more knobs and dials that you have, the more likely there are going to be more people tweaking them. If you're using a queuing system, that's yet another dial that somebody might change, that they install some patch to the queuing system that makes it work differently than how it did before. The more moving parts that you've got, and that was the question that was raised before, the more moving parts that you've got, the more likely that they're going to get out of sync with each other, and then something's not going to work. So it's important to understand the bigger and the more complex the distributed system is, the less likely that there's going to be any one person that understands how everything works. So you do invest in some kind of configuration management. Take the time to slow down, document things, create well-known, stable run points, back up the system. These are things that your administrators should know how to do. The reality is many of them don't. And then what happens? They call us in, right? They say, something doesn't work. You go figure it out, right? You wrote the system. You should be able to figure it out. And then you're going, line by line debugging things, and you're not really sure why it's not working either. So understand that this kind of stuff is just going to get worse. Now, in configuration management, it's a well-known field. Read up on it. There's a standard around this. It's called ITIL, I-T-I-L, that documents a lot of the practices and models and do this and don't do that and follow these checklists. A lot of that is out there. The thing is that specifically for those of you working in the smaller companies, usually less of this is known or already applied. So you kind of need to figure it out as you go along. The fast-growing startups, who said just eat? Was it you? Yeah. So when there's a fast-growing startup, that's usually a canonical place where these things fail repeatedly. It started small and we just kind of hacked, and then we found some business success and it started growing rapidly. And then kind of it's inventing the car while you're trying to drive down the road. So a lot of this stuff has been documented. Start there, don't reinvent the wheel. I want to talk briefly about high availability. High availability is one of those things that's often, as developers, we consider administrators will be doing that. The thing is that even if all of the machines are up and running and your database server is working, when you're deploying your software to production, especially when you already have an existing version in production, a lot of times that can result in some downtime. So that's actually one of the interesting linguistic dichotomies. Upgrade equals downtime. All right? And that's why often we get pushback from the business that they say, oh no, don't touch anything. We've just ran a major marketing campaign. Oh no, don't touch anything. This is Black Friday. Oh no, don't touch anything. The CEO needs to give a talk at a conference. And why? Because they know anytime that a developer, an ops person is going to be touching the system, something is going to break. So we get pushback, and then that results in us making even bigger upgrades. Because we're not just going to sit there twiddling our thumbs for weeks until Black Friday and the Christmas and the holiday season is over. We write more and more code, and the more and more code that we write, the more changes that we make, the higher the likelihood that when we do an upgrade, something is going to break. That's exactly backwards. We need to go the other way around, into continuous deployment. To deploy so frequently that deployment becomes a non-concern. And then through that process, automating as much of it as possible. And one of the concerns here is making sure that the code that we're deploying is backwards compatible. If you want to be able to upgrade without downtime, that means that you're going to need to change one server while leaving another server running the old version. In essence, it's running version n and n+1 side by side live. If you can do that, then if the physical machines are highly available, then the system will be highly available. If you can't do that, that means every upgrade is going to require downtime. Backwards compatible code is difficult to write. Microsoft, they get lots and lots of crap. But really, they're one of the best companies, historically speaking, in terms of creating backwards compatible software. I mean, you can still run crappy Visual Basic apps on top of Windows 10. That is amazing, really. On the flip side, you get companies that get all of the kudos, like Apple, who every single product release, they break compatibility with everything else that they've ever done. It's like, oh, you like those iPhones, the earphones? Yeah, we've removed the jack. That charger that you just bought for your last iPhone, it's not going to work with the next iPhone. All right? But everybody loves them. You know, it's Microsoft does, you know, they make a mistake around backwards compatibility and everybody tears into them. Backwards compatibility is hard. But if you want to build highly available services, it's one of those things that you need to think about and start planning for and start testing as a part of your regular testing process. It's hard enough to test a distributed system. Imagine the difficulty of testing different versions side by side. It's something that you need to invest in. No administrator is going to solve that for you. That's part of the DevOps continuous deployment story. If you can't do that, don't go down the continuous deployment path. That's sort of a prerequisite. Otherwise, continuous deployment is going to equal continuous downtime. And nobody wants continuous downtime. All right? So, just reiterating some of the things I said before, consider multiple versions running in parallel. That's always going to be an issue. It means make smaller changes to more loosely coupled pieces of code. You do that systematically, it's going to end up working out. I'm going to get back to this thing in just a second. Enable administrators to take down parts of the system for maintenance, not the whole thing all at once. Queues help a lot in this regard because they provide that temporal decoupling where one part of the system can continue enqueuing messages while the other part of the system might not be pulling the messages off of the queue. So a lot of the things that we mentioned before are easier once you've introduced queuing, but it's not that queuing is the only way to do that. Back to this bullet point over here. How to pinpoint problems in production. Logging is kind of one of those solutions where a little bit of it is fairly good, but too much can be harmful. So let me phrase it this way. Who's had a problem where they're trying to debug something in production, or let's not call it debug, to troubleshoot something in production, and they couldn't find the problem in the log files? Okay. Now, the problem with this that we just had, that everybody raised their hands, is that the solution that we end up with is, let's log more. When you're looking for a needle in a haystack, you don't go and create ever bigger haystacks. Makes sense, right? But as an industry, that's what we've been doing. We've been creating bigger and bigger haystacks, and then we've created infrastructure in order to be able to process those haystacks at a larger and larger rate. And that was one of the reasons why queuing technology morphed into event stream type technology like Kafka, where it's well, we've got all of these logs and we need to really move them across the network really quickly. It's all about the haystacks. We need to focus more on the needles. Or if you'd like to think of it, use that metaphor slightly differently, we need better magnets to be able to pull out those needles from the haystack rather than doing more logging. So some logging can be helpful. I'll talk about some messaging patterns as we go forwards to help us pull these things out. But for now, just think of that metaphor. Needles and haystacks don't make bigger haystacks, all right?